Hello students, welcome to this short lecture in which we are going to connect model of atom, quantum numbers, electronic configuration with periodic table. We have already learned in second unit atomic structure about various models of atom. At present, the situation is that to explain all the properties of atom, we need Bohr's model as well as quantum mechanical model of atom. Bohr's model is actually two-dimensional. It is also not appropriate on the basis of de Broglie's relationship and Heisenberg's uncertainty principle, which do not support existence of orbits, the stationary states in which electrons are revolving as explained by Bohr. According to wave mechanical model or quantum mechanical model, which considers electrons as waves propagating in positive field of nucleus, and there are regions around the nucleus where probability of finding electron is maximum. But electron is having mass also. That means it is having particle nature as well. And we concluded that electron has both particle nature as well as wave nature. So we compromised that electron is both a wave and particle, and we consider Bohr's model as well as quantum mechanical model in our problem solving techniques and to explain all the phenomena taking place in which atoms are involved. Okay, so this we have learned about model of atom in our 11th class syllabus. Then we also learned quantum numbers, which give us address of electron in an atom. First three quantum numbers, principal quantum number, azimuthal quantum number, and magnetic quantum number, these three quantum numbers are the constants which are used to solve Schrodinger's wave equation. And if we consider electron as a particle also, then we need spin quantum number also. You learned all these four quantum numbers and you solved many practice problems and you cleared this concept. Okay. And then by using these quantum numbers, you also filled electrons in atoms, in orbitals of atoms. Electrons are in orbitals are in subshells, are in orbits of atoms, and atoms are everywhere. All matter is made up of atoms. Okay. And you made electronic configurations by using Aufbau principle, Hund's rule, then Pauli's exclusion principle. And now in next unit, we are going to study modern periodic table. We will connect all our this knowledge with modern periodic table in this very short lecture. So try to understand everything you know. Nothing new I am going to explain you. We are just going to connect our knowledge and clear our concepts. Okay, let us begin. So our today's topic is relation between quantum numbers, electronic configuration, modern periodic table, and model of atom. Okay, so to explain you all these four things, I have divided my slide into four parts. This upper left part, N, L, M, and S, these are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. And on right side, upper right side, we will show energy levels. Okay. And lower left side, you see a blank modern periodic table. And on lower right side, a central, this dot is here. What is this? This is a nucleus, a very dense mass having protons and neutrons around which there are electrons. Bohr says electrons are revolving in circular paths, but as per quantum theory, there are some regions around the nucleus where probability is maximum. So we will see how these things are correlated. Okay. Now, let us begin. Value of principal quantum number n can be 1. If it is 1, it means we are in first orbit of an atom. Around the nucleus, there is first orbit. If value of n is 1, you know quantum number L will be 0 because value of L is 0 to n minus 1. It begins from 0 and goes up to n minus 1. So 0. If n is 1, L is 0. And 0 means, you know, s orbital. And if L is 0, the value of m will be also 0. Because you know, value of m is minus L through 0 up to plus L. And 0 is 0. 0 can't be negative or positive. So value of m is 0. Value of m 0 means there is one value of m. There is one orientation of electron. And value of s, you know, is either clockwise or anti-clockwise. If electron is particle, it is spinning. The spin of electron is either clockwise plus 1 by 2 or anti-clockwise minus 1 by 2. This line is slanting upward. That is showing plus 1 by 2 clockwise. Okay. So if n is 1, L is 0, m is 0, value of s is plus 1 by 2. And on energy diagram, we are showing it by a circular, this region. It is called orbital. It is s orbital. It is just represented by this circle. It is a space where probability of finding electron is maximum. So this is one s orbital. Okay. Now electron is shown by an arrow. If arrow is upward, it is clockwise. Downward, it is anti-clockwise. And the atom which is having only one electron has this quantum number. And its electronic configuration is 1s1. Okay. And on modern periodic table, it lies here. You know, it is hydrogen. And if we draw its picture, model, what it will be like this. You know, shape of s orbital is spherical. There is a spherical region around the nucleus, this nucleus, where we can find it. Okay. So in this way, quantum numbers, electronic configuration, modern periodic table, and model of atom are related. Now let us go ahead. Now, one more electron can be accommodated in s orbital because, you know, according to Pauli's exclusion principle, an orbital can accommodate two. More than two is not possible. So, and if two electrons are there, the spin of both will be opposite. You say this is opposite arrow, clockwise, anti-clockwise. Now, one s orbital is filled fully. Now, the atom which is having two electrons, which is having atomic number 2, has these values of 4 quantum numbers. It is its electronic configuration 1s2. And in modern periodic table, that element is lying here. You know, it is helium, atomic number 2. And model will remain same. In this region, two electrons can be accommodated. This is a wave mechanical model. Two waves are there. Spin of one electron is clockwise, other is anti-clockwise. The model will remain same. Now, principal quantum number n when becomes 2, the value of L will be 0 as well as 1. 0 is possible, 1 is also possible. And if L is 0, that means S subshell. For S subshell, again, similarly, M is 0 and one clockwise electron is there. And in electronic configuration, one more circle is drawn. This is 2s orbital. Okay. And this is one electron. So EC of this element is 1s2, 2s1. Energy of 2s is higher than 1s. And on modern periodic table, this element is lying here, lithium, atomic number 3. And the model of lithium will look like this 1s2, then 2s. 2s orbital is again s. It will also be having a spherical shape, but it will be bigger in size. And there will be a region where probability of finding electron is minimum, which is called node. Okay, so you can see here, the inner one, blue one was 1s orbital having 2 electrons. And the next one, the bigger one, is 2s orbital. Both are having spherical shape. The difference between the two is 2s is bigger than 1s. And 2s is having one node, one region of minimum probability. Now, one more electron can come in 2s orbital. Here, anti-clockwise arrow is shown. And that element in modern periodic table is here, beryllium. Model will remain same because 2s orbital can have one more electron. It can have maximum 2 electrons. Okay. Now, principal quantum number n remains 2 and value of L can be 1 also. When value of L is 1, it means it is p subshell. When it is p subshell L is 1, the value of m can be -1, 0, as well as +1. If it is -1, that means an orbital. Okay, we call it px. Similarly, if it is 0, we call it py. If it is +1, we call it pz. Means it is having 3 orbitals, px, py, and pz. And this one electron, if atomic number is 5, there are 5 electrons, 1s2, 2s2, and 2p1. So electronic configuration goes like this, and on table, that element will be here. Okay, because last electron has entered into p subshell. So this is a p block element. This concept is also clear here. Okay. Now, in model of atom, p subshell is shown like this. You have learned that p orbitals are dumbbell shaped, slightly bigger than 2s in size. And in this dumbbell shape, the probability of finding electron is maximum. Okay. And if it is 0, 0 means another orbital. This orbital shown here, it is also having an electron like this. And according to Hund's rule, pairing of electrons in orbitals of same subshell will not take place until all orbitals are half-filled. That's why we have not paired them up. And one more thing, when orbitals are half-filled, the spins of half-filled electrons will be same. When 2 electrons are in same orbital, their spins are opposite. When 2 single electrons are in orbitals of same subshell, their spins are parallel. Their spins are same. Okay. So this is atomic number 6, 1s2, 2s2, 2p2. You know, it is carbon. On modern periodic table, it lies here. It is also a p block element. Last electron is entering p subshell. Okay. Now, on model of atom, it is shown by this dumbbell. This is, you can say py. If this is px, this is py. If this is px, that will be py. Both are parallel, both are perpendicular to each other. Okay, both are having dumbbell shape. Now, plus 1. Plus 1 means this third orbital of p subshell. It is also dumbbell. If it is also having an electron, that will also have same spin, parallel spin, clockwise. Okay. And in this table, that element will lie here. And in this model, that pz orbital will be perpendicular to both px and py. If it is perpendicular to px and py, that means it will protrude towards yourself. It will come out of your screen and go behind your screen. You will be able to see only its head. You see, it is not a sphere. It is a dumbbell, which is on z-axis. You are able to see only its head. I hope you are understanding what I'm saying. Okay. Now these three orbitals can have one more electron each with opposite spin. There is still space. Okay. Now, if atomic number is 7, one electron goes here. On table, it is lying here. Atomic number 8, one more electron goes here. In table, it is here. Atomic number 10, one more electron. The model remains same. Okay, interesting. It is very informative, I think. Now, when principal quantum number becomes 3, value of n is 3, it means now we are in third orbit of an atom. The value of L will be 0, 1, and 2 as well. 0 means S subshell, 1 means P subshell, and 2 means D subshell. D subshells will also come into play here. Okay, so 0 S subshell, just as before. Now try to understand yourself. I will not speak. Yeah, you see, again, a spherical region, sky blue color. It is bigger in size than earlier, than 2s, and it will be having two nodes of minimum probability. It can have 2 electrons. Okay, so this is sodium, and it is magnesium. Then if L is 1, it is P. Again, P orbitals, which are dumbbell shaped, 3p. See here. The shape of 3p is also dumbbell. What is difference between 2p and 3p? Both are dumbbell, but 3p dumbbell is bigger in size than 2p dumbbell. And similarly, difference of nodes is there. You have learned that formula to find out number of nodes in an orbital. You can use it. Okay. Then second p orbital, perpendicular to px. Then third p orbital, which is perpendicular to both these. Again, you are able to see only its head because it is protruding towards you. Okay. And again, each of these three orbitals can accommodate one more electron having opposite spin. So model will remain same. Elements going in modern periodic table, electronic configuration is going like this. Now, D subshell. D subshell, when value of L is 2, value of M will be -2 through 0 up to +2. There are 5 values. But you must remember that energy of 4s is lesser than 3d. So before 3d, electron goes to 4s. That is why in electronic configuration on the axis of energy, 4s has appeared first. Okay. So n value 4, L value 0. there are two electrons. So one more still bigger spherical region, which is representing 4s orbital. It can have two electrons. This is 4s2. And after this, 2d will come into play. -2, -1, 0, +1, +2, 5 orbitals. And shape of d orbital is double dumbbell. That double dumbbell will go here. Again, this shape will get more complicated. There are 5d orbitals, maximum 10 electrons can be accommodated. Okay, see this. So these 10 elements are lying here in D block of modern periodic table because their electron is entering to D. After that, similarly, 4p, that F as other orbitals come and model is clear. Okay. I hope that this presentation must be of great information to you and helpful to you. You are now able to grasp the matter better. Thank you for watching. Please keep on sharing and liking. Thank you.